Alright, here we go. So I've got a 2 kilogram box pushed with a 10 Newton force and it experiences 2 newtons of friction. What is its acceleration? So to actually figure this out, I'm going to draw a free body diagram. So I have the normal on the box, I have its weight, and I apply this gravity force horizontally. Now, I'm going to write down every numerical fact about this box that I can. So I know that the normal force and the gravity force balance. If the gravity were bigger, the box would crash through the table. And if the normal force were bigger, the box would fly up into the air. So I have that the normal force balances the gravity force. Great. And let me actually get a number for that. So previously we talked about the fact that the gravity force is the mass times the gravitational strength. This is m, and this is g. So what I just found out is that my normal force is 20 newtons and balances my gravity force. So I have 20 newtons here and 20 newtons here. And the other thing that they tell me is that there's 2 newtons of friction, so that actually opposes the motion. So in the horizontal direction, so I'm going to say this is vertical, and in the horizontal direction I have the friction force, so horizontally. I have the applied force F. It battles the friction force. These don't cancel. They're not equal to each other, so they can't balance. So the effect of these two forces is that the mass accelerates. So when I write sigma F, this is a shorthand for summing the forces, just as I've done here. So I have a 10 Newton force opposed by a 2 Newton friction force, and I have a 2 kilogram box that accelerates. So when I solve for that acceleration, the acceleration ends up being 4 meters per second squared. In the next video, we're actually going to do a more complicated problem where I'm going to get you set up.